We are given with a question here. A body is projected horizontally from the top of a tower with velocity of 30 meters per second. The velocity of the body 4 seconds after projection is. So here, let me draw the projectile. Since it is projected from the top of a tower horizontally, this will be a horizontal projectile. And we know the path of the projectile is going to be parabolic. With what speed it is projected? 30 meters per second. So it is going to follow a parabolic path, something like this. Now here the question is we need to find the velocity of the body after 4 seconds. Now just understand how do we solve this problem. To find the velocity of the body after 4 seconds or after any time, first assume that particle may be somewhere here. Anywhere during its path, the particle may be somewhere here. How do you find the direction of velocity? By drawing a tangent. First you draw the tangent and that will represent the direction of velocity. Now velocity is going to have two components. One is the horizontal component Vx and one more is the vertical component Vi. We have to break the projectile into horizontal and vertical analysis, and that's how we do the problem. Before starting any projectile, I have always told you to resolve the initial velocity and make a note of the acceleration. So here the velocity is purely horizontal, so no need to resolve. So what is the initial velocity along x-axis? Since it is purely horizontal, ux is 30 meters per second and there is no velocity along the y-axis initially, it is equal to 0. And what is the acceleration along the x-axis and what is the acceleration along y-axis? Whenever you're doing a projectile problem, you make sure that you're resolving the velocity and noting down the accelerations so that we can get to know what kind of motion exists along what axis. Here, the only acceleration is the gravity, which is along the negative y-axis. So ay, since it is downward, it is minus g, and there is no acceleration that exists along the x-axis. Therefore, acceleration along the x-axis is 0. Therefore, the motion along the x-axis is uniform motion along the x-axis, and along the y-axis, uniformly accelerated motion. Acceleration is constant along the y-axis. Now, what is the equation that we can apply along the x-axis? V equal to S by T. And what equations can we apply along the y-axis? All the kinematic equations can be applied. All the kinematic equations we can apply along the y-axis. So here, how do we find Vx? We know along the x-axis, the velocity will remain same because along the x-axis uniform motion. So velocity is going to be constant all the time. Velocity is going to be constant all the time along the x-axis. So velocity along the x-axis will be same as the velocity that is 30 meters per second. Along the x-axis, velocity is going to be constant every time. That is 30 meters per second. How do you find velocity along the y-axis? We can use the kinematic equations. We have to find out velocity after a time of 4 seconds. After what time we have to find? After a time of 4 seconds. So since we have to do the y analysis, what are the parameters you know along the y-axis? You know, initial velocity along the y-axis is 0. Ay is equal to minus g. Time, you know, it is equal to 4 seconds, and we have to find out Vy. So I can easily use the equation V equal to U plus AT. V is equal to U plus AT. We can use the equation. So since it is along the y-axis, we can write it as Vy equal to Uy plus Ay into T. How much is Vy? Vy is unknown. Uy is how much? Uy is 0. Acceleration along the y-axis is minus g, which is minus 10 into time is nothing but 4. So that will become equal to minus 40 meters per second. Minus just indicate it is in the downward direction. So I found the velocity. So we have two velocities. So one is Vx, which is 30 meters per second. And this is Vy, which is nothing but 40 meters per second. Minus just indicates downward. How do you find the net velocity? Using the parallelogram law. The net velocity V is equal to, according to the parallelogram law, it is a root of Vx square plus Vy square. Or you can also write it in the vector form and then you can take the magnitude. So that is equal to root of 30 square plus 40 square, and that is a root of 900 plus 1600, and that is nothing but 2500, and that is nothing but 50 meters per second. That is the velocity at time t equal to 4 seconds. Option number 3 will be the solution.